So here we're testing to see what is this symmetry. So first off, let's remember this is just critical. This is super critical. Everything. Y is the same thing as f of x. So we're just going to replace that. Bigger marker. F of x. So f of x equals 4x squared over x squared plus 1. And then we're going to do what we did before. So what did we say we were going to do? We were going to find f of negative x. So remember what that means. That's critical that you can see how to do that. So just like if we were finding f of 2, that would mean replace all of the x's with 2. If we're doing f of negative x, that's going to mean replace all of the x's with negative x. So we're going to have 4 times negative x squared. See how we replace that x with a negative x over negative x squared plus 1. So that's f of negative x. And now our task is to simplify and see what we end up with. Well, negative x squared, a negative times a negative just ends up being a positive. So that negative x squared just turns right back into a normal 4x squared. And this down here on the bottom, negative x squared, that also just turns into a positive x squared. And so look what happened. We found f of negative x, but we just ended up with the original function. And so that's what we're saying. When we plug in a negative, we just get the same thing as when we plug in a positive. So that means we have y-axis symmetry, because we just showed that f of negative x is equal to just the original f of x. So it has y-axis symmetry. And let's go ahead and just check it out on Desmos, because anytime we have an opportunity to see a potentially pretty graph, I don't think we should pass that up. So 4x squared divided by x squared plus 1. Ooh, look at that. That's almost like a little reverse normal curve. If we toss a negative into the front of it, it almost is like a little normal curve. Not totally, though. Like it's got steeper in the middle, sharper in the middle. Still a nice looking graph, But definitely, as you see from the graph, y-axis symmetry. And here's what's neat. I don't know, well, so look how like everything has an even power in this function. Like it's not written, but this here is technically x to the 0, right? So everything has an even power. And look how if we change one of these, like if we change that to like a 1, we make it have an odd power. Well, actually, look at that. Just that change there made it have x-axis symmetry. How did that work out? Let's try that. So that's our new function. So let's call it g of x. So this is just a new problem. Let's say that we have g of x is 4x over x squared plus 1. So now what happens when we find g of negative x? Well, we have 4 times negative x over negative x squared plus 1. So now see, it's different because the 4 times the negative x on the top, now we just have negative 4 over, then the same thing, negative x times negative x is positive x squared plus 1. Oh, whoops, that x is still there. And so look what happened now. If you have a negative on the top of the fraction, that just means the whole fraction is negative. So we could pull that out to the front if we want. And look at that. That's our function. That's our original function. But now it's negative. So what did we do? We found g of negative x, and we just showed that it's equal to negative g of x. And that means that it is an odd function, because g of negative x is equal to negative g of x. And we see when we look at the graph that that is totally true. That is odd, or that is origin symmetry. When we flip that back up to the top and then flip it back over, it lands back in on itself. So one last thing I need to clear up is I kind of just realized I might have been using these interchangeably. When we talk about y-axis symmetry, if something has y-axis symmetry, we call that an even function. largely because that's functions like, or not y squared necessarily, but y equals x squared. Y equals x squared, they have y-axis symmetry, it's a parabola, and that's what we call it an even function. And then if it's a origin symmetry, kind of matches in the letters at least too, we call that an odd function. And those are just like definitions, those are just like synonyms, those are interchangeable. And we call it an odd function because, like we already said, those are functions like y equals x cubed. Something like y equals x cubed has origin symmetry. And it's also x to the third, which is why we call it an odd function. And as it might suggest by the name, any odd power, x to any odd power will be an odd function. X to any even power will be an even function. And while we're still talking about this, if you start adding a bunch of stuff together, like for example, if you have this, or even like again something like this is going to be an odd function because look at how all of the powers are odd. If we did just something like this now all the powers are not odd. One of them is even. So this function would be neither odd or even. But then if we went back and we changed all of the powers to being even, now it's an even function. And what's always been kind of cool to me is you can even add something like a plus 2. And it'll still be an even function. Why? Because that's like 2 times x to the 0. And 0 is even. And that's just even more concrete shown that if all of these are odd powers, but then we have a plus 2, that means it's not an odd function because all of the powers are not odd. This one cuts it because this was a power of 1. But if this is just a plain 2 here, that's x to the 0. That's an x to an even power. That means that whole function is going to be neither because some of the powers are odd, some of the powers are even. So that was a lot. That was a lot to cover in one video. The gist of it is these two things right here. That it has y-axis symmetry and it's an even function if you find f of negative x and it's just equal to the original function, and you know that it has origin symmetry. I'll write that here. Origin symmetry if g of negative x or f of negative x, that doesn't have to be any specific letter. Remember, those are just kind of variable names. If f of negative x is equal to negative f of x. If you plug in negative x and you get out the original function, just the negative version, then it's an odd function. And if you don't get either of those things, which frankly is what would happen most often to any like random function, be more likely that it would just be neither. So there's nothing wrong with that. Don't be afraid when that happens.